We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the image of the upper half plane in the given context in the question paper, and this question is from the complex analysis. This question is from part B, which is a multiple choice question carrying 3 marks with the question ID 704033. The given question is, let H is equal to the set of all complex numbers Z such that imaginary part of Z greater than 0 denote the upper half plane, and let F be a function from C to C, the set of complex numbers to the complex numbers, in other words from the complex plane to itself, is defined by f of z is equal to e power iz. Which of the following statements is true? We are given H, the upper half plane, and f is a function from complex plane to itself defined by f of z is equal to e to the power of iz. Now, the statements, which of the following statements is true? We are given 4 options. Option 1, f of h, the image of h under f, is the whole of the complex plane except the origin. Option 2, f of h intersection h is countable. Option 3, f of h is bounded. Option 4, f of h is a convex subset of C. Let's now discuss the solution of the problem in detail. We have H, the upper half plane, given by the set of all Z belongs to C, such that the imaginary part of Z greater than 0. That's our complex plane, organ plane, and imaginary part of Z greater than 0, that is Y greater than 0. Y is equal to 0, that is the real axis is not included, and all the points that lie above the real axis denotes H, that is the upper half plane. Right. We are given a function f from the complex plane to itself defined by f of z is equal to e to the power of iz. Now, let us say w is equal to f of z, right? We normally denote f of z by w. That means it will, from the complex plane C to C it will go. W is u plus iv, so it will be mapped into the other part of the organ plane, right? The other organ plane, right? So w is equal to f of z is equal to e to the power of iz. So write for z x plus iy, then e to the power of ix into e to the power of minus y, I into iy, I square y, that is e to the power of minus y, right? Now, mod w is equal to mod fz is equal to mod of e to the power of ix into e to the power of minus y. So, mod of the product is equal to product of their mods, that is the mod of e to the power of ix into e to the power of mod of e to the power of minus y. Mod of e to the power of ix is mod of cos x plus I sin x, that is equal to under the square root of cos square x plus sin square x, which is 1. So, you will get mod of e to the power of minus y. We have written it as e to the power of minus y because it is always positive, and that is equal to 1 by e to the power of y, and y is greater than 0. Now f of h is equal to the set of all f of z where z belongs to H. For all z belongs to H, we have mod of fz is always greater than 0. Therefore, 0 is less than mod of fz is equal to 1 by e to the power of y. Because it is z belongs to H, it is in the upper half plane y greater than 0. That implies 0 less than mod of fz is less than 1. 1 by e to the power of y, y greater than 0 will be less than 1. For all z belongs to H. So this will tell you for all z belongs to H, this is 0 less than mod of z less than 1 tell you f of H is bounded by 1. Right. So this implies f of H is equal to W is equal to f of z such that 0 less than mod W less than 1, and this is obviously bounded. Right. So what is it? It is a unit open disk punctured at the origin. It is a unit open disk punctured at the origin, and that is bounded, and thus our option 3 is true. Our answer to this question is option 3. And having known that option 3 is true, there is no point in proving option 1, option 2, option 4 are not true using the fact that f of H is bounded. And if you do not know f of H is bounded, and if you want to eliminate the other options, then you eliminate 3 options, then you say the leftover option is an answer. That is the answer normally students will do in the examination. But if you know that certain option is true and using it the other options are not true, that in any manner it will not serve any purpose. They will be, naturally they are not true. They are not true because this is true. Because it is a MCQ where only one question, where only one option is true. So we have already proved there is no point in proving the others are not true using this fact. But anyway, normally people will be satisfied by doing that way also. So I will also show you that kind of stuff here. So that's what we have done. Right. Let us take option 1. F of H is C minus the origin. Now this is the whole C minus the origin. And it is very clear that your f of H, the punctured open unit disk, is a proper subset of C minus the singleton 0. It's very clear. So note that f of H is a proper subset of C minus 0. Therefore, the option 1 is not true. Therefore, f of H is not equal to C minus the singleton 0. Therefore, option 1 is not true. But mind you, you are using the fact f of H is bounded and it will look like this one. So you are using and the option 1 is not true. So when you know it that option 3 is true, stop there. That's all. There is no point in proving all these things are not true. If you do not know anything, then you eliminate 3 of them. The others will be the leftover. The other will be true. Right. Anyway, option 4. Let us take f of H is a convex subset of C. Right. So now recall, a set A is convex if the line segment between any 2 points in A lies completely in A. That means it will be a convex set. If the line segment between any 2 points, you take any 2 points joined by means of a straight line, that line segment must completely lie in A, and this is to be true for every pair of points, then A is said to be convex. Now, I will take on x-axis minus 1 by 2, that is somewhere here, and plus 1 by 2. These are the 2 points, and the line segment joining them is the straight line joining minus 1 by 2 to plus 1 by 2, which passes through the origin. But the origin does not belong to your set, your f of h. Therefore, it's not completely line because the origin does not belong to that one. So, we see that the line segment between the points minus 1 by 2 and 1 by 2 of f of h does not lie completely in f of h. Why? Because it passes through the origin, and the origin does not belong to f of h. Therefore, f of h is not a convex subset of C. So, and thus the option 4 is not true. There is another option that we do in the next slide. Right, we have proved option 3 is true, option 1 is not true, and option 4 is not true. We go for option 2. F of h intersection h is countable. So, f of h intersection h is what? So, let us first of all look for the diagram. That is the argand plane, and that is f of h. This is the blue, this yellow one is the f of h, and this violet one is the upper half plane. If you take the intersection, then it is the semicircle, not including the circumference and the real axis. And how do we say that? It is a set of all z. Z is equal to r e to the power of I theta. We take a polar representation. 0 less than or less than 1, 0 less than or less than 1, and 0 less than theta less than pi, less than, not included. So that is the one, and the intersection part, f of h intersection h, is the mixed color one, this one. It is obviously, it is an uncountable set. It's an uncountable set. If you do not follow that, so I will show you. You take a convenient point and describe a neighborhood which is entirely contained in it. It is possible to do so because it is an open set. And every open neighborhood is uncountable. And that is contained in this f of h. And that is uncountable, contained in f of h. So, f of h is also uncountable. So, note that the neighborhood with the center at I by 2 and radius 1 by 4 is uncountable because it is an open neighborhood. All open neighborhoods are uncountable. And this neighborhood is entirely contained in f of h intersection h. I will show you here. See this one. So, this is the point I by 2, this is the point I by 2 and 1 by 4 radius, and describe an open neighborhood which is entirely contained in it, f of h intersection h, and this neighborhood is uncountable. So, now we say f of h intersection h is uncountable, since every superset, f of h intersection h is a superset of this neighborhood, and every superset of an uncountable set is uncountable. So, therefore, your option 2 is not true. So, combining all these things, the answer to this question is option 3, where we have shown that it is a bounded set, and the option 3 is true. And that is the detailed discussion of the solution of this problem. from the section complex analysis. I am sure that you have understood the solution of this problem, and if you like my videos, please like, share and subscribe my channel. I wish you all the best. Thank you.